Welcome to ACE Engineering Academy. This is Vavi Ramaya. We are going to discuss how to crack ISRO exam, Indian Space Research Organization. Here it is the Government of India sector. Today we are going to discuss some questions. Before that, you should know the importance of our subject. Our subject title is ISRO series, branch CSC, and subject COA, Computer Organization and Architecture. Here, weightage analysis of our subject. First of all, it is the weightage. Here, its syllabus is almost equal to GATE syllabus. And earlier we had 80 questions. Each question carried 3 marks, total 240 marks. But now onwards, by collecting the information from so many sources, we concluded some additional topics are also added in the upcoming exams. Those are nothing but aptitude and ability. Here, 80 questions are there. All are MCQs. Here, new pattern is like this. We collected this one from most of the reliable sources. New pattern is like this. In this 80 number of questions, these are nothing but MCQs. And each question carries 1 mark. At the same time, negative marking is also there. Negative marking is also there. These are nothing but MCQs. Negative marking 1/3. Here, in these 80 questions, only technical questions. Apart from these, 20 more questions, aptitude and ability. So, final conclusion is like this. Total number of marks would be 100 marks. Okay, now, if you observe this weightage of our subject from 2007 onwards, 7 4 questions, 8 13 questions, 9 14 questions, 11 14 questions, 13 8 questions and so on, 2020 11 question. Here, among all our technical subjects, operating system has highest priority, topmost priority. Next, computer networks is having second highest priority. And third highest priority subject is nothing but our COA. And at the same time, according to my knowledge, so many aspirants, means so many students are not interested to prepare this subject well, because so many students didn't get proper knowledge on this subject while studying their bachelor degree. That's why the mark what you have secured in this subject, each and every mark what you have secured in this subject, nothing but a deciding factor. Here, it is the main point in our main criteria, means how to crack ISRO. In this, main criteria is solving of the most of the questions from our subject. Next, syllabus. Look here, the syllabus is almost equal to the GATE syllabus. And if we observe the previous ISRO papers, most of the questions, more than 70% questions are nothing but the previous year's GATE questions. Those are simply copied and pasted here. That's why if you practiced well those questions, GATE questions, these question solution becomes very easy, especially in our subject. Most of the questions are nothing but previous gate questions, and the syllabus is also same. And apart from this syllabus, 8085 and 8086 microprocessor questions were there. These are also nothing but basic questions. After watching the previous ISRO papers, I have observed 4-5 microprocessor questions. Those are related to 8085 microprocessor and 8086 microprocessor. Remaining entire syllabus is almost equal to the gate syllabus. In this, first of all, machine instructions and addressing modes, ALU data path and control unit instruction pipelining, memory hierarchy, cache memory, main memory, secondary memories, IO interface, interrupt and DMA, finally computer arithmetic. Along with this, some basics are needed from 8085 and 8086 microprocessor. Okay, let us start to discuss our important questions from our subject. Before that, tips for the preparation. While preparing for ISRO, select the order of the subject. First, you should select the order of the subject. Next, means while preparing for COA subject, first of all, better to complete the digital subject first. It is nothing but the proper order, means sequence, how to prepare the subject one after another. Next, listen the lectures. It depends on the availability. Next, prepare the short notes. While listening the lecture, prepare the short notes. Solve all PYQs, all previous year questions. Test series provided by ACE Academy. These are the tips for our preparation. Next, come here. First question. This question was given in 2009. This question is related to computer arithmetic topic. A processor that has carry, overflow, and sign flag bits as part of its program status word. Program status word means flag register. Performs addition of the following two 2's complement numbers. It is the first number and it is the second number. After the execution of this addition operation, the status of the carry, overflow, and sign flags respectively will be. Watch the question carefully. He asked to add two numbers. Each number size is 8-bit. For this, look here. First number is 01001101 plus second number is 11101001. For this, perform addition. Now, here, these data are represented in signed 2's complement notation. He mentioned the same thing in the given question. That's why MSB tells the sign of the data. In this, first data belongs to positive, second data belongs to negative. After adding one positive data and one negative data, compulsory overflow flag will be reset. It is impossible to occur the overflow after adding one positive data and one negative data. That's why here he asked the status of carry, overflow, sign flags respectively. Middle one is nothing but carry flag. Middle one is nothing but overflow. That's why A is wrong and C also wrong. So what about the correct options? B or D, look here. 1 plus 1, perform addition. 1 plus 1, 0 with carry 1. 1, 1, 0, 1, 1, 0, 1, 0, 1. What it is? Carry. Ninth bit is nothing but carry. Next, what about this one? It is nothing but sign flag. Okay. In system style, it is also known as C out. But in this question style, it is nothing but carry. So it is nothing but sign flag. So in this case, overflow. First he asked the carry. First he asked the carry. Carry flag is 1. Next, overflow. Nothing but 0. Next, what about next one? Sign flag. Nothing but 0. So correct answer is 1, 0, 0. Correct answer is B. At the same time, look here. If you want to find the overflow, one more technique is also there. In system style, it is nothing but C out, it is nothing but C in. These two are applied for one XOR gate. XOR gate inputs are nothing but C in and C out. In this, both are 1. Here it is 1 and it is 1. Automatically, output of XOR gate is 0. Means overflow not occurred, means no overflow. It is the another technique. And simple technique is, after adding one positive data and one negative data, overflow should not be occurred. Next, come to next question. This question also related to same computer arithmetic first topic. Look here, the addition of 4-bit 2's complement binary numbers 1101 and 0100 results in. Here, size of each data is 4-bit. First data is 1101, second one is 0100. Here, first data 1101, second data 0100. Already we discussed, after performing addition operation on one negative data and positive data, no overflow occurs. That's why A and D are wrong. Correct answer can be B or C. What about the value of this one? It is nothing but, the decimal value of the same is nothing but 1, 2, 4, minus 8, nothing but minus 3. 1, 2, 4, minus 8, nothing but plus 1, plus 4. So result is nothing but plus 1. So finally, plus 1 in 4-bit signed to 2's complement notation. Sign symbol is positive, means MSB is 0. So remain 1 is nothing but 0, 0, 1. So correct option is C. 0, 0, 0, 1 and no overflow. This question was given in 2009. Next, look here. What is the decimal value of the floating point number C1? 0, 0, C1 0, 0, 0, 0, 0, 0. Look here. Watch the question carefully. What is the decimal value of the floating point number C1D 0, 0, 0, 0, 0, hexadecimal notation? Assume 32-bit. Assume 32-bit single precision floating point IEEE representation. This data is represented in IEEE standard 32-bit notation. Now in this, he asked the decimal value of the same. Look here, in this it is S. Total size is 32 bit. S tells the sign of the data. Here it requires 1 bit and it is nothing but biased exponent. In our style, capital E represents biased exponent. Here its size is 8 bit and remaining 23 bits are used for mantissa. Mantissa is represented in signed magnitude form. In this, biasing value is nothing but 127. Now, you have to produce the given value C1D00000 in the 32-bit register and divide the data according to this format. Look here, C1D 0, remaining 4 are zeros, means its size is 32 bit. C1D00000 in hexadecimal means 32 bit, 8 4 32 bit. C means 1100, 1 means 0001, D means 13, 1101. Remaining all are zeros. Total size is 32 bit. Here it tells the sign and 8 bits are reserved for, look here, 8 bits are reserved for biased exponent. So 1, 2, 3, 4, 5, 6, 7, 8. It is nothing but capital E, nothing but M. Mantissa is expressed in signed magnitude notation. So value of the expression is like this. Expression value is nothing but -1 whole power S into 1.m into 2 power capital E value minus B value 127. It is the expression value. Then -1 whole power 1 is nothing but, it is nothing but minus 1.m is nothing but 101000 up to 23 bits into 2 power. Here capital E value is nothing but 1, 2, 4, 8, 16, 32, 64, 128. Biased exponent means it is unsigned. Its decimal value is nothing but 131. So 131 biased exponent value is nothing but 131 in decimal. Already we know biasing value is nothing but 127. So its result is nothing but 4. Now, when this exponent became 0, then this binary value directly provides the decimal value. Now it is nothing but minus. To get 0 in this place, you have to shift the decimal point to right for 4-bit position. When this exponent became 0, not needed to consider these values. So it is in binary. So it is decimal point here. It is in binary. Its decimal value is nothing but 1, 2, 4, 8, 16. Nothing but minus 16 plus 8, 24, plus 2, 26. So value is nothing but minus 26. Hardly it takes 2 minutes. When you are having familiarity in this expression, it hardly takes 2 minutes. Excellent question it is. And expect a question from IEEE standards, that also in single precision notation, means 32-bit notation. Come to next question. When two n-bit binary numbers are added, the sum will contain at the most means after adding 2 number of n-bit data, what is the longest result size? It is the meaning of the given question. Now in this, after adding two number of n-bit data, the longest result size is nothing but n plus 1 bits. Highermost bit is nothing but carry. So here, answer is nothing but D. For this, further exercise is not required. After performing multiplication on two number of data, let those data sizes are m and n. Then longest result size is nothing but m plus n bits. But after adding two number of n-bit data, the longest result size is only n plus 1 bits. Another question from computer arithmetic. Excellent question it is. Here, when you are clear in concept, the solution also takes maximum 1 minute time. 1 minute time is more than enough to solve this question when you are having clarity in the signed 2's complement notation characteristics. When you are having clarity in the signed 2's complement notation characteristics, this solution becomes very easy and it takes maximum 1 minute time. Look here, two data are given. First one is nothing but m, second one is nothing but n. Each data size is 8-bit. Watch the question. Two 8-bit numbers in 2's complement notation. Their product in 2's complement is, he asked the result of a product in signed 2's complement notation, signed magnitude notation, signed 1's complement notation and signed 2's complement notation. These are used for representing signed data but not for unsigned data. Here, while representing positive data, no complement is required for magnitude. Positive data is represented in normal format, means direct format, but negative data is represented in the complement given in the notation but not in direct format. Now look here. What about m value in decimal? This question is given in 2017. First you find the m value in decimal. M is nothing but 11111010. Its size is 8-bit given in 2's complement notation. Then by using sign bit extension technique, except this bit, these 4 bits are nothing but guard bits or dummy bits. Don't consider the value of the same. It is nothing but sign bit extension technique. Sign bit extension is a step for converting smaller size, here 4-bit data to 8-bit by padding the sign bit to left. In this, minimum size of the data is 4-bit and it is expressed in signed 2's complement notation. That's why its decimal value is, MSB sign is negative. That is nothing but -6. What about n value here? N value is nothing but 0, 0, 0, 0, 1, 0, 1, 0. Now, with the help of sign bit extension technique, these three are dummy. Now its value is nothing but 1, 2, 4, 8, -16 means +10. Then product of -6 into +10 is nothing but -60 in decimal. Express the same in 2's complement notation. It is nothing but, to represent -60 we require -64. Next 32 not required, 16 not required, 8 not required, 4 is required, 2 and 1 are not required. Now its size is 7-bit, but he gave the answer in 8-bit. That's why 10001000. Use sign bit extension technique. Sign bit is extended to left. So what about correct answer? 1100 0100. So correct option is A. These are the techniques, tips used to solve the given question at shortest time. Next. Here one more question is there related to IEEE standard. Already we have solved similar type of question. That's why go for next chapter. This question was given in 2007. The principle of locality of reference justifies the use of. It is belonging to cache memory concept. Meaning of the question is locality reference is given by cache because in a computer system, cache memory occupies topmost position. Cache memory occupies topmost position and cache memory is used to store the current executing files, means location of the current program execution. Because of that reason, it provides the locality reference. Okay, excellent question it is. This question was given in both CSC branch gate paper and IT branch gate paper. Earlier, from 2004 to 2008, there was separate gate paper for CS and IT branches. The same question was given in IT branch gate paper and CSC branch gate paper. That's why it is compulsory needed to remember the answer of this question while solving the ISRO questions. Look here. This question also related to cache memory mapping techniques. First, understand the same. Consider a small two-way set associative cache memory. Consider a small two-way set associative cache memory consisting of 4 blocks. Number of cache lines is equal to 4. One cache line is nothing but 1 block. Here in our style, CL means number of cache lines. How many? 4. Those are nothing but CL02, CL3. Next, associativity 2. N is nothing but associativity. Next, for choosing the block to be replaced, it uses the LRU technique. LRU means least recently used. Means the block which is not referenced by the processor from longest time will be selected for replacement, and the number of cache misses for the following sequence of the block addresses is dash. Here he gave the block numbers sequence, means processor requires these blocks in proper sequence. These are nothing but main memory block numbers. Now he asked the number of cache misses, means the total number of misses. What's the question? First one, 8, 12, 0, 12, 8. Now, here mapping expression is nothing but K mod S. What K tells? Main memory block number, these numbers. Here S means number of sets. Here, how you compute the S value here? Number of cache lines by associativity. Here, number of cache lines is equal to 4. Associativity is equal to 2. So, number of sets is 2. That's why mapping expression is K mod 2. Okay. Now, order is 8, 12, 0, 12, 8 for this. Look here. Here only two sets are there, set 0 and set 1. Here first request is nothing but 8. You write the order here once again, 8, 12, 0, 12, 8. Here first request is 8. 8 mod 2 means remainder is 0, means 8th block number maps to set 0. Here initially it is empty, that's why here 8 maps to set 0. It is nothing but miss. When a block is referred first time, it is nothing but compulsory miss. Which type of miss it is? CMP, compulsory miss. Next, second one, 12. 12 is also not there. That's why 12 also maps to set 0. It also maps to here only. It is also compulsory miss. Here, each set permits only 2 cache lines because associativity is 2. Now, set 0 has been filled. Whenever processor wants to map another block in set 0, one of these two must be evicted with the help of LRU technique. Processor most recently spoke to 12, least recently spoke to 8. What about next one? Next one is nothing but 0, not there. To permit 0, 8 is replaced with 0 because processor most recently spoke to 12, least recently spoke to 8. So for 0, it is also compulsory because 0 has been mapped first time only. Next, again 12. 12 is already available. That's why it is not miss, it is hit. But you should write 12 here because assume processor will be available at right side. Means processor most recently spoke to 12. After this, least recently spoke to 0. Because of that reason, you have to change the order position of the block number. Next, 8. 8 is not there. So 0 is replaced with 8. For 8, it is not first time, it is second time. That's why it is not compulsory, it is conflict. So in this, total number of compulsory misses is nothing but 3. First 3 are compulsory and conflict miss is nothing but 1. So total number of misses is equal to 4. So what about correct answer? 4. Excellent question it is. Come to next. This question also related to memory. Look here. Number of chips 128 into 8 RAM needed to provide the memory capacity of 2048 bytes. Means here target size is 2048 bytes. What does it mean? 2048 bytes means each byte capacity is 8 bit. It can be written as 2048 into 8 bits. 8 bits. Now, basic capacity. Basic means available chip capacity. Nothing but 128 into 8 bits. That's why total number of these chips needed is nothing but target size by basic size. It is nothing but target size is nothing but 2048 into 8 by 128 into 8. Here cancel this size of the word here and here means 1. Here 2048 divided by 128, nothing but, here it is nothing but 2 power 7, it is nothing but 2 power 11, means 2 power 7 by 2 power 11 means 2 power 4, nothing but 16. So our answer is 16. So correct option D. Hardly it takes half minute time. Now, excellent question it is. Look here. Consider a direct mapped cache with 64 blocks and a block size of 16 bytes. Here 64 blocks are there. Type of mapping is direct mapping and block size is 16 bytes. To what block number does the byte address 1206 map to? He gave the address of a byte, means address of a word. Look here. Given word address is nothing but 1206. Find its binary value first. 1206 means 1024. 1024, we require 1024. I am going to explain shortcut. Next 512 not required. 256 not required. Next 128 required. Next 128 required. Next 64 is also required. Up to this what we are getting? 16. 1216, but we require only 1206. That's why. Look here. Otherwise, divide the 1206 with 2, then also we get the answer. But it is better to write once again. When you are having clarity in this, you can able to solve the question at shortest time. That's why better to learn this concept well. Here, it is nothing but 1024. Next 512 not required. Next 256 not required. Next 128 required. Means here 1152. Next 64 not required. 32 required. Here 1152 plus 32 means 1184. Next 16 means 1200. 8 not required. Next 4 and 2 are required. Next 1 is not required. If you add all these weights, answer is nothing but 1206. Once again, 1024 plus 128 means 1152 plus 32, 1184 plus 16, 1200 plus 6, 1206. Now it is the address of a word. It is the address of a word. Look here. Once again write the address. 100110110. It is the address of a word. Later, it is the direct mapped cache. Direct mapped cache physical address format is like this. For direct mapped cache, physical address format is like this. Physical address format, nothing but a tag. Left side field is nothing but a tag. Next, line offset, cache line offset. Next, word offset. Here offset means address bits, number of bits needed to select the given parameter. Now it is nothing but the total number of bits needed for addressing a word in the physical memory, nothing but physical address. Now from this, here if you observe this, a block has 16 bytes. To select one of the 16 bytes, it requires log 16 4 bits. At the same time, it has 64 blocks. To select one of the 64, it requires 6 bits. It requires 6 bits. To select one of the 64 lines, it requires 6 bits. Remaining are nothing but tag. For solving this question, not needed to discuss the tag size and physical address size. Here it is very, very, very important. Now, here, look here. 1, 2, 3, 4. It is nothing but word offset. Word offset means address of a word. Address of a word. It is nothing but 0100 means word 6. Now 1, 2, 3, 4, 5, 6. It is nothing but a tag. Left side one. Nothing but cache line offset means 6 bits are required to select one of the 64 lines. Its decimal value is 1, 2, 4, 8, 16, 32. It is nothing but 11. So it is nothing but cache line 11. So answer is 11. Okay, na? Next. Next, look here. Another question, it is also related to memory. Already we have solved this type of question earlier, and at the same time it takes maximum half minute time. How many 32K into 1 RAM chips are needed to provide a memory capacity of 256K bytes? Target capacity is nothing but 256K into 8 bit. Basic capacity is nothing but 32K into 1 bit, because he mentioned clearly nothing but 8, nothing but 32K, 8 times to 256K, 32K into 8, 256K, so 8, 8, 64. So our answer is 64. It takes hardly half minute time. Next. Look here. This question is related to secondary memories, hard disk, magnetic hard disk. What's the question? Consider a disk pack with 16 surfaces. Number of surfaces is 16, 128 tracks per surface, and 256 sectors per track, 512 bytes of data stored in a bit serial manner in the sector. The capacity of the disk pack and the number of bits required to specify a particular sector in the disk are respectively. First understand the question carefully. Read the question carefully. First try to understand the meaning given in the question. First try to understand what he gave and what he asked. If you understood the question, solution becomes very easy. Look here. Consider a disk pack with 16 surfaces. Here, H represents number of surfaces because one head is required to operate one surface. That's why we took H for representing number of surfaces. 16 means 2 power 4. Next, number of tracks per surface is 128. T is nothing but 128 means 2 power 7. Next, and 256 sectors per track. S is nothing but 256, nothing but 2 power 8. And 512 bytes data are stored in one sector means B is equal to 512 means 2 power 9. Here H tells number of surfaces in the hard disk, T tells number of tracks in one surface, S tells number of sectors in one track, B tells number of bytes in one sector. What he asked first? The capacity of the disk pack and the number of bits required to specify a particular sector. Means he asked the data storage capacity of the hard disk and the number of bits required to select one of the sectors in the entire hard disk. Okay? Now look here. Data storage capacity is nothing but data storage capacity in hard disk is nothing but H into T into S into B. It is nothing but h is nothing but 2 power 4 into 2 power 7 into 2 power 8 into 2 power 9, nothing but 2 power 28 bytes. 2 power 28 means 2 power 8 into 2 power 20 means 256 megabyte. 256 megabyte. 2 power 20 is nothing but mega. At the same time, from this you conclude one thing. Option C and D are false. Correct answer can be A or B. What about second one? He asked the number of bits required to select one of the sectors in the hard disk. For this, select next page. First of all, it is nothing but surface offset. What does it mean? Number of bits needed to select one of the surfaces means log h with base 2. Later, track offset. What does it mean? Number of bits needed to select one of the tracks in the selected surface, so log t. Next, later, sector offset means number of bits needed to select one of the sectors in the selected track, nothing but log s. From this, look here, number of surfaces is equal to 2 power 4. That's why this field requires 4 bits. It is used to select the one of the surfaces. Later in that surface, how many tracks are there? 2 power 7. To select one of the 2 power 7, we require 7 bits. After selecting the track is the collection of sectors, and each track is having 256 sectors, means 2 power 8, means 8 bits are needed to select one of the sectors. So total number of bits needed to select one of the sectors in entire hard disk is 4 plus 7, 11 plus 8, 19. Number of bits needed to select a sector in the track is nothing but 8. But in question, he asked the total number of bits. Number of bits needed required to specify a particular sector in the hard disk. Means it is nothing but not 8. 8 plus 7 plus 4 means 19. So what about correct option? Correct option is nothing but A. Now look here. This question is related to basic processor organization, means CPU design. Watch this question. In which addressing mode the effective address of the operand is generated by adding constant value to the content of a register? Well, understand the question. In which addressing mode the effective address of the operand is generated by adding a constant value to the content of a register? Means it is nothing but he gave the effective address generation. Here, to generate the effective address, constant is needed to add for the given register. Then effective address is obtained. Now it is known as computable addressing mode. Addressing modes are basically divided in two ways: non-computable and computable. Computable means ALU operation is needed to generate the effective address. Here plus is nothing but addition is nothing but ALU operation. AM is nothing but addressing mode. So here, option A, absolute addressing mode. It is non-computable addressing mode. Non-computable. Indirect, it is also non-computable. Immediate, non-computable. Index, yes, computable. In index addressing mode, effective address is nothing but constant, also known as the displacement, plus content of index register. So correct answer is D. Now look here. Excellent question it was. This question also related to basic processor organization and design. Now in this, this question was given in 2017 paper, December paper. Now, consider an instruction of the type LW. LW means load a word R1, 20 bracket of R2, which during execution reads a 32-bit word from memory and stores it in a 32-bit register R1. Next, the effective address of the memory location is obtained by adding a constant 20 and content of R2. He mentioned the way of generating the effective address, nothing but 20 plus R2. Which one best reflects the source operand? He asked the type of addressing mode. It is computable addressing mode. Now, options are like this: immediate, non-computable; register, non-computable; register indirect addressing, non-computable; indexed, yes. In indexed addressing mode, constant means offset value, means displacement value is added to the given register. Which register it is? Index register. So correct answer is D. Now, another question given in 2020. A stack organized computer is characterized by the instruction with indirect addressing, direct addressing, zero addressing, index addressing. Stack organized computer is characterized by instructions with. Here, indirect addressing. Stack memory. Operation requires push R and pop R instruction. Push R and pop R instructions. Push R instruction is used to write the R content on stack. Pop R instruction is used to read the stack content to the specified register. Here, while executing push R and pop R instructions, SP means stack pointer provides the address of the stack. That SP is not given in the instruction. Instructions are nothing but push R and pop R. That's why SP is a register used to provide the address of the stack memory. That's why it is register indirect addressing mode. At the same time, some more clarity is needed in the question. Here, stack related arithmetical operations are performed with zero addressing. It becomes correct answer. It becomes correct answer for performing stack related arithmetical operations. But in question, it is this information is not given. A stack organized computer is characterized by instruction with indirect addressing. If the question format is like this, 100% it is correct answer. But in the question, if he mention this point for performing stack related arithmetical operation, then Zero addressing becomes correct answer. Small conflict is there in this question. That's why you should understand the question clearly. Next, it is related to pipeline operation. The performance of a pipeline process suffers if. It is related to pipeline process topic. The performance of a pipeline process suffers if. The question is given in 2008. Look here. A. The pipeline stages have different delays. When pipeline stages are having different delays, means those stages are operated with uneven intervals, then some of the valuable time is wasted. Because of the longest delay consumed by the one of the segment, see here segment is nothing but stage, remaining all segments will be stalled, then it degrades the system performance. Next, consecutive instructions are depending on each other, nothing but data dependency conflict. Next, the pipeline stages share hardware resources, means pipeline stages share hardware resources, means same hardware resources, means which one suffers the performance of the pipeline processor. For this all, correct answer is all. Here next question, excellent question, given in 2011 on pipeline only. Okay. A processor takes 12 cycles to complete an instruction I. The corresponding pipeline processor uses 6 stages with the execution times of 3, 2, 5, 4, 6 and 2 cycles respectively. What is the asymptotic speed up? Assuming that a very large number of instructions are to be executed. Look here. Once again, a processor takes 12 cycles to complete an instruction I. Corresponding pipeline processor uses 6 stages with the execution times of 3, 2, 5, 4, 6 and 2 cycles respectively. What is the speed up assuming that a very large number of instructions are to be executed? In this, nothing but speed up expression is nothing but non-pipeline time by pipeline time. Here, understand the question. A processor takes 12 cycles to complete an instruction I. Number of clock cycles needed to execute one instruction on non-pipeline is nothing but 12. How you conclude it is non-pipeline? Because in next statement, corresponding pipeline processor uses 6 stages. The corresponding pipeline processor uses 6 stages means first one is nothing but non-pipeline, because second one is nothing but pipeline. That's why non-pipeline time for one instruction is 12 clocks, where pipeline processor uses 6 stages and delay is not in uneven. What is longest delay? 6. That's why longest delay is nothing but segment delay time. T segment is nothing but longest delay time, nothing but 6 clocks. While executing large number of instructions in pipeline processor, one segment time is sufficient to complete one instruction. Here you have to take longest time, nothing but 6 clocks. It is nothing but 2. So what about the speed up? 2. Okay. Next, compared to IO organization and control unit design, here it is better to discuss the microprocessor questions. Before that, one excellent question is there on IO organization. Look here. In DMA transfer scheme, the transfer scheme other than the burst mode, DMA means direct memory access. DMA can be operated in 3 modes. First one, DMA can be operated in 3 modes. First one, burst mode, also known as continuous DMA. Next, cycle stealing. Next, interleaved DMA. First one, cycle technique, stealing technique, cycle stealing technique, cycle bypass technique. So correct answer is cycle stealing. Other than burst mode, cycle stealing. Last one is interleaved DMA. Next, come to 8086 and 8085 processor basics, because we had some questions in ISRO papers. That's why better to discuss basics of the same. The address space of 8086 microprocessor CPU is, look here, this question was given in 2008. .8086 microprocessor CPU has, microprocessor is also known as a processor, CPU machine. It has 20 address lines. That's why address space is nothing but a 2 power 20 bytes. It uses byte addressable memory but not word addressable memory. That's why 1 megabyte. So answer is A, where 8085 microprocessor has 16 address lines. It also uses byte addressable memory. So data storage capacity means address space is nothing but 2 power 16 bytes. 2 power 16 bytes means nothing but 64 kilobytes. If we gave the question for 8085, answer is 64 kilobyte, but for 8086 answer is 1 megabyte. Next, look here. It is also related to 8086 processor. Move BX bracket, comma AL, type of data addressing is dash. AL content goes to, AL means 8-bit register content goes to address. That address is given by BX register. That's why it is register indirect addressing, because bracket is there. Next, look here. Which interrupt in 8085 microprocessor is unmaskable, means non-maskable. Non-maskable, nothing but unmaskable. Here, 8085 microprocessor is having 5 number of hardware interrupts. In these, except trap, here RST 7.5, RST 6.5, RST 5.5 and INTR. All these are maskable except trap. All these are maskable. But trap is non-maskable. Unmaskable means non-maskable. Here, trap is also known as RST 4.5. Sometimes trap is also known as RST 4.5. Correct answer is C. Okay, now practice all these questions, and at the same time, here ACE Academy offers self-paced programs. Here full course recorded programs are available in online, and QRC quick revision courses are also available. When you are having limited amount of time for writing the respective exam, better to purchase a QRC quick revision course program. And we are having plenty time, means flexible time, better to purchase full length program. At the same time, along with these course programs, test series questions are also available, and previous questions, PYQs are also available. These are the separate modules, and RRB module also available, ISRO module also available. Okay, finally, best of luck. Thank you very much.